At the end of the last video, I gave you this assignment. First of all, just graph cosine of x, which is our parent function, so I've got that up here. And then to graph these two transformations. So I started on this one. We're graphing cosine of x over 2. In evaluating that, the first thing I would do is divide x by 2, which of course is equivalent to multiplying by 1/2. And then I would plug into cosine, which is my parent function. Now, since I'm dividing by 2 before I plug into cosine, that means this is a horizontal transformation. Counterintuitive. So dividing by 2 I think of as making things smaller. We're going to stretch things and make everything twice as big. And of course, I accomplished that. Let me just label that this was y equals cosine x. Now I'm going to graph y equals cosine of x over 2. Okay. I accomplished that by doing the opposite of this to my important x values. So instead of dividing them by 2, I'm going to multiply them by 2. So my first important x value was 0, times 2 is still 0. Pi over 2 times 2 is going to become pi. Now, in the interest of space, I'm not actually making this twice as big as it was up here, just because I'd run out of board space. So I'm using a different scale down here. My next important x value was pi. Doubling that will make it 2 pi. 3 pi over 2 doubled is 3 pi. 2 pi doubled is 4 pi. So now these are my important x values. Important y values have not changed. Okay. And we're not doing anything vertically. So we're going to start high, then middle, low, middle, high, and we play connect the dots. Okay, and I asked for the period. You can see the length of time it took to do one thing was 4 pi. So when we doubled all of our x values, we doubled the period. Okay. Now, if I want to graph y equals cosine of negative x over 2, I mentioned, I'm going to just move this label over here, that I'm always going to deal with a negative on the inside by taking advantage of the fact that cosine is even, or if I'm working with sine, sine is odd. So this is saying my input is the opposite of x over 2. Opposite input for an even function gives me the same output. So that negative sign does not affect the shape of the graph at all. These two graphs look exactly the same. So I labeled this as y equals cosine of x over 2. I can also label it as cosine of negative x over 2. Those graphs are exactly the same, and they both have a period of 4 pi. Okay. All right. So I want to just real quickly review the functions that we've had and the period that they had when we were working with these sines and cosines of multiples of things. So we looked at sine of 2x, and then we looked at sine of negative 2x, and we looked at cosine of x over 2, and we looked at cosine of negative x over 2. Okay. For sine of 2x, we said, if you remember, the period was pi. Okay. Because multiplying by 2 here was a shrink. So we ended up taking our important x values and doing the opposite of multiplying by 2. We cut them in half, and that cut the period in half. It was the same period here, because the period is the length of the interval over which the function goes through one cycle. Cosine of x over 2, we just saw the period was 4 pi, and same thing here. So dividing our x values by 2, we ended up taking our important x values, doubling them when we were graphing, and so that doubled the period and made it 4 pi. As a general rule, if I have y equals sine of bx or y equals cosine of bx, the period is going to be 2 pi divided by the absolute value of b. Okay. Notice here I was multiplying by 2. Absolute value of 2 is 2. 2 pi divided by 2 would give me pi. Here we were multiplying by negative 2. Absolute value of negative 2 is positive 2. 2 pi divided by 2 would give me pi. The period must be positive because it's a length of an interval. Here, I often think of that as dividing by 2, but essentially in this case my b is 1/2. I'm multiplying x by 1/2. Okay, so 2 pi divided by 1/2, well, the way I multiply by a fraction, the way I divide by a fraction is I multiply by the reciprocal, so that became 2 pi times 2, which was 4 pi. Okay. Here, we were multiplying by negative 1/2, but the absolute value of that is 1/2. 2 pi divided by 1/2 is 2 pi times 2 is 4 pi. So, whatever number you're multiplying x by, the period is going to be the usual period for sine or cosine, which is 2 pi, divided by the absolute value of that number. Now, your book gives you this formula, but in a slightly different way. The book just says the period, if b is positive, is 2 pi divided by b. Because, of course, if b is positive, then the absolute value doesn't do anything. So they're sort of assuming that if you have a negative number for b, that you deal with that by using the fact that cosine is even or sine is odd first, and then calculate the period. I think it's simpler to just say whatever b is, whether it's positive or negative, in calculating the period, I'm going to use the absolute value of it. So that's what I'll generally do, but I just wanted to point out that when you're looking in the book, you won't see that absolute value, but you'll see a caveat that b must be positive. So they're expecting you to make b positive. If there's a negative number, use the evenness of cosine or the oddness of sine to move that negative. Either it goes away or it moves to the outside. Okay.